Welcome all. Today we are going to discuss the 21 AM 45, the computer organization and architecture course. So this course we are having 5 modules. First module represents basic structure of computers, and second module represents input output organization. Third module represents memory system. Fourth module represents arithmetic and basic processing unit, and fifth unit represents pipeline and vector processing. So in this course we are having totally 5 course outcomes. So first 4 outcomes represents explain the organization and architecture of computer system with the machine instructions and programs. Second course outcomes analyze the input output devices communicating with computer systems. Third course outcome represents demonstrate the functions of different types of memory devices. Fourth outcomes represents apply different data types on simple arithmetic and logical unit. Then fifth course outcome represent analyze the functions of basic processing unit, parallel processing and pipelining. So today we are going to discuss the first module. In that first module we are going to discuss basic operational concept and bus structure. So what is computer organization and architecture? So this is the course name used to design the computer system. Then computer architecture is considered to be those attributes of a system that are visible to the user, like addressing techniques, so instructions, sets and bits used for data and have a direct impact on the logical execution of a program. Now we need to find out that identify what is the difference between computer organization and architecture. So here are the few differences. So computer architecture means what, and computer organization. So here computer architecture represents, architecture means the overall structure it will represent, that is computer system structure and behavior as seen by the user in concerned here. So like that in computer organization it represents the connection of the computer's hardware system is concerned with forming a computer system, but here it is a behavior of the seen by the user is concerned here. So second thing is we decide on computer architecture while designing computer system. So coming to the computer organization, we decide organization after architecture while designing a computer system. So next, how the computer system designing is done is described here in computer architecture. In organization, so how the computer systems works is described here. These are the 3 main fundamental difference between computer organization and architecture. So as per the syllabus we need to go through that. So basic structure of computers. So basic structure of computers. So one thing is one side is input devices, output device and center is CPU. So all the input devices connected to the CPU. Again CPU divided into 2 parts. One is control units, second one is ALU. One is memory and second one is ALU. So ALU contains arithmetical logical operations and first one is memory devices. Now here, so all the registers connected to the main memory or memory, basic structure of a computer. So here, so we can see that, so MAR, MDR, control unit, all these registers are connected with memory. So control unit, that is bidirectional, MDR bidirectional and MAR is only one direction. What is this MAR, MDR and control unit and PC, IR, and these are general purpose register and ALU. Now, so this is a MAR, that is memory address register. So it is responsible for addressing various locations in the memory. And second one is MDR, the memory data register. So it is responsible for read and write data to and from the memory. And third one is control unit, is control all the activities happening between the registers, it will control that. Next, PC is the register, is comes under a processor. So that is PC represent program counter. So it stores the address of the next instruction to be executed. And section one is instruction register, stores the instruction which is under execution. Then here R1 to up to Rn-1, this represents as general purpose register. It is responsible for storing required data related to program execution temporarily. So addition to that we are having ALU, that is arithmetical logical units. It is responsible for handling all the arithmetic operations and logical operations. So this is the overall structure of basic operational concepts of the computer. We can consider as basic operational concepts. Next, here in this basic structure of a computer, so activity in the computer is governed by instructions For example, we can take one simple example. What is the instruction? So instruction is, so we are taking, so here one example is there. So this example represents add LOC A RO, that is add A. So it represents A is a register, it stores in the accumulator. So add A comma B. So we can represent add A comma B or A plus B storing in the B. That is a one thing. Add A plus B storing in the A. Both are correct. So it represents what is the instruction? Add register A to B. So A plus B, it will stored in the A or B. So it depending on the processor. In Motorola processor, we can consider as, so B is equal to A plus B. Then in a Intel processor, we can consider as A is equal to A plus B. So it depending on the processor. So both instructions are correct. So majority, whatever we are giving the instruction, add or store or load, so based on that all the register it will work. So here another example, add LOCA RO, load ROCA comma RI, so then R1 comma R2. So this is the one instruction we can give. Next we are moving to the next topic, bus structure. So what is bus? Bus is a collection of wires is called a bus, right? So bus structure in a computer plays important role in connecting the internal components of the computer. So what are the internal components? Internal components we can consider as, so input devices, output devices, processors, whatever registers are we are connecting, that you can consider as a internal components of the computer. The bus in the computer is the shared transmission medium. This means multiple components or devices use the same bus structure to transmit the information signal to each other. So we can go to the simple bus structure. So this is a single bus structure. So all the bus components or units connected to the this single, right? That's why you can consider as a single bus structure. So input is a connected and output we are displayed. So memory is bidirectional because we are storing all the information, and processor, what are the things are the communicating. So that is we can consider as here processor. So in the single bus is a collection of wires. Here three signals will pass. One is data signal, address signals and control signals. All these things are connected to this single bus. If we consider that, next thing, so this is the main bus structure. So in this bus structure, so we can show that control lines, address lines and data lines, and it is connected with the processor and memory. So here we are connecting with input output devices up to n number of devices. So we can represent this overall bus structure. Now we can consider what is this signal represent. Data means what, address line means what, and control line. So data lines means, so coordinate in transferring the data among the system components. The data lines are collectively called data bus. So all the data whatever we are sending, that we can consider as a data only. A data bus may have 32 lines here, or 64 lines, or 120 lines, or even more lines we can consider here. So each data line is able to transfer only one bit at a time. Only one bit we are transferring here, right? So next we can consider as second thing, second one, so address line. So address line, the content of the address lines of the bus determines the source or destination of the data present on the data bus. The number of address lines together is referred to as the address bus. So this is the second line, address bus. And we are moving to the third one, that is a control. Data line, address line and control line. So control lines, the address lines and data lines are shared by the components of the system. So there must be some means to control the use and access of data and address lines. The control signals placed on the control lines, so control the use and access to the address and data lines of the bus. The control signal consists of the commands and timing information. So all the things whatever storing and getting information, all the things are controlled by control lines. Okay, so data lines representing a data, so one bit at a time it will move. Address lines, it represent the what is the address of that data. Then control lines which control the all the activities of the system. So now what are the activities, what are the control lines operations we can consider? One is memory write also comes under control line, then memory read, input output write, input output read, transfer acknowledgement, bus request, bus grant, interrupt request, interrupt acknowledgement, clock and reset. So these are the control lines. So these are operations controlled by control lines. Okay, today we discussed basic operational concept of the computer and bus structure. Okay, so once again I recall. So in the basic operation concepts, it contains memory and processor. Memory, it stores all the information, and processor contains the register MAR, MDR, the program counter, ALU, then IR, then program counter and general purpose register. These are things are connected with memory. That is basic operational concept we discussed. Second thing is bus structure. So single line bus structure and multiple line. So all the lines having three signals. One is control, address and data. So these are the things, control lines operations. Thank you.